The aim of operating the chemostat is to obtain the maximum dilution rate. So let us see a graph. This is change in dilution rate. It is going to be the unit as time inverse. So when dilution rate is going to be 0, if x is going to be the y-axis, we will get a maximum biomass concentration when dilution rate is equal to 0. That means the system is going to be operate like a batch reactor. When we are increasing the dilution rate, means d is equal to f by v, where v is going to be constant. Only f alone is going to be increased. If you are increasing the f, the biomass concentration will remain maintained for quite long period. After some times, since the residence time of the substrate in the reactor is going to be reduced, then the maximum biomass concentration will reduce drastically, and after over a period of time, biomass is going to be 0. The point at which the biomass is getting 0 in the reactor is called as washout time. Understand? Similarly, when the biomass is going to be maximum, the substrate concentration in the reactor is going to be 0. When the biomass is getting reduced, then the substrate concentration in the reactor as well as in the exit is increased similarly, and whenever the substrate biomass concentration is reaching 0, the substrate concentration will reach the maximum of S0 concentration. So this is going to be the S concentration in terms of gram per liter. So this is going to be S0. So when you are operating the dilution rate, when D is equal to mu, we will get mu or mu net, we will get the washout period. So we cannot operate the reactor with biomass. Only the substrate will enter in and it will go out. There won't be any biomass inside the reactor. To optimize this dilution rate only, what we need to do is we have to differentiate the dilution rate along with the biomass to get the maximum biomass concentration. Okay, so to avoid this point of washout period, what we need to do is it should be operate with dx. That means we know x is the biomass concentration, that can be mentioned as x is equal to x0 plus yx by s of s0 minus s. We take this as equation number 11. Since x0 is equal to 0, we will write the biomass concentration in x as yx by s is equal to s0 minus s. I told that it must be operated along with x should be operated along with the d. So multiply with the dilution rate d of this equation 12. So dx is equal to yx by s of d of s0 minus s. This is going to be equation 13. Substitute equation 10 in 13. Equation 10 in 13. Then dx is equal to yx by s of d of s0 minus, what is s means, dks whole divided by mu max minus d. Take this as equation number 14. Differentiate equation 14 with dx, the d of d, then d of dx divided by d of d is equal to 0. D of dx is equal to d. Then we can simplify this equation 14